Hello, everyone. This is Dr. Scott Haggerty, and let me start tonight with a question. How many of you have been told your child has retained primitive reflexes and you left thinking, okay, so now what? Maybe you were given exercises, maybe you've been doing them faithfully, maybe you've seen progress and then regression. If that's you, tonight is going to bring clarity because here's what we're going to do together. By the end of this webinar, you will understand where primitive reflexes actually live in the brain, why they stay active, and why stress and the vagus nerve matter more than most people realize, and what the correct starting point really is. And here's the most important thing. Primitive reflexes are rarely the root cause. They're a signal. And when you understand what they're signaling, you stop chasing symptoms and you start supporting development. So let's build this really from the ground up. So this is the brainstem. It's composed of the midbrain, the pons, and the medulla, as you can see here on screen. This is the automatic control center. It runs heart rate, digestion, startle, muscle tone, basic survival responses. Primitive reflexes are wired here. They travel through pathways like the reticulospinal tracts and the vestibulospinal tracts. These are ancient motor pathways. They're fast, they're automatic, and they are protective. And here's something important. At birth, the system is supposed to dominate because the higher brain, the thinking brain, is not fully developed yet. So if your baby had strong reflexes, that was healthy, that was normal. The question isn't why did the reflex exist? The question is, why didn't it quiet down? Here's the shift most people miss. Reflexes don't disappear, they are suppressed. The cortex, especially the motor cortex and the prefrontal cortex, develops downward control. That downward control travels through something called the corticospinal tract. Think of it like the brain's brake pedal. As that pathway myelinates or gets coated with myelin, meaning it gets insulated and stronger, it sends inhibitory signals down to the brainstem. When that inhibition is strong, reflexes stay quiet. When inhibition is weak, reflex stays accessible. This is why primitive reflexes reappear in adults after stroke or brain injury. It's not that the reflex was fixed, it was inhibited. And when inhibition is lost, the reflex reemerges. So reflex retention in children is rarely a defect. It's an inhibition issue. That is a completely different conversation. Now, let's layer in stress. The locus coeruleus, that little blue structure, is your alarm bell. It releases norepinephrine. When stress becomes chronic, this system fires more frequently. Research by Arntzen in 2009 showed that chronic stress reduces prefrontal cortex firing. So what happens then? The brake pedal weakens. So now we have more brainstem level activation, less cortical inhibition. And primitive reflexes live in the brainstem. Do you see the pattern forming? This is not in any way, shape, or form random. So here's the loop visually. It's stress to locus coeruleus activation, then brainstem arousal increases, cortical inhibition drops, reflex expression increases. Now here's the part that most people miss. When reflexes stay active, posture feels unstable, movement feels unstable, emotions feel unstable, and instability creates more stress, which then feeds the loop. That's why just doing exercises sometimes doesn't really hold, because the stress circuit is still running underneath. So instead of asking, how do we eliminate the reflex, we should really ask, what's keeping the brain in survival mode? So the vagus nerve here is the master controller, master regulator. It feeds into the brainstem at a place called the nucleus tractus solitarius. From there, it connects into the locus coeruleus, the amygdala, the stress and anxiety center, and the prefrontal cortex. Research on heart rate variability shows that strong vagal tone correlates with stronger emotional regulation and better prefrontal function. When vagal tone is low, sympathetic dominance rises, brainstem reactivity rises, and inhibitory control weakens. And primitive reflexes become more likely to remain active. This is why so many kids with retained reflexes also have anxiety, sensory sensitivity, poor sleep, GI struggles. Same network, same circuitry, same story. This diagram shows the two-way street. The body sends information up and the brain sends regulation down. If vagal tone is low, the body sends threat signals upward. The brain then stays in protection mode. So you can't cognitively override that. You have to regulate it. That's why bottom-up approaches matter. So the cerebellum is often misunderstood as just balance. It's much more than that. It coordinates movement timing, sequencing, eye tracking, emotional rhythm. It communicates with the frontal lobe through the cerebellothyromocortical tract. When cerebellar data is clean, inhibition strengthens. When cerebellar data is unstable, tone fluctuates, coordination drops, and inhibition weakens. A researcher named Schmamann even describes something called dysmetria of thought, or clumsy thinking and clumsy emotion, when cerebellar modulation is off. Let me restate that. Dysmetria of thought is clumsy thinking and clumsy emotion when cerebellar modulation is off. So again, reflex retention is rarely isolated. It's network-based. If the body feels unstable against gravity, the brainstem pulls the fire alarm. Reflexes activate. It's always going to be safety first. The brain will always choose protection over refinement. That's intelligent, not pathological. So proprioception acts as the brain's GPS. Every spinal joint has mechanoreceptors. They send constant input to the cerebellum, the brainstem, and the cortex. If movement is restricted, that map gets really blurry. A blurry map equals threat interpretation by the brain, and the brain defaults to survival circuits. So research by Dr. Heidi Horvick has shown that spinal adjustments can alter how the brain processes sensory input. Havik and Murphy demonstrated changes in somatosensory evoked potentials, things that the brain receives. Niazi and colleagues showed changes in cortical drive after spinal manipulation, what we call adjustments. This doesn't mean adjustments erase reflexes. It means altered input can change processing. So here's the way this works. Better input, better processing leads to stronger inhibition, and stronger inhibition allows reflexes to quiet naturally. So reflex exercises train movement patterns. But if the nervous system itself is still dysregulated, if stress physiology is still dominant, if cortical inhibition is weak, then drills won't hold under pressure. Our order is like this: regulate autonomics first, improve sensory input, support cerebellar modulation, strengthen cortical inhibition, then refine motor patterns. You've got to calm the storm and then teach the skill. So it works like this: assessment, stabilization, maturation. Because the reflexes aren't gone, they are properly inhibited by a resilient brain. Ultimately, moms and dads, that's the goal. Not suppression, maturation. If you're interested in doing some of your own research, the research studies here that I referenced tonight are all listed here. These are peer-reviewed studies supporting the mechanisms we discussed tonight. This is just straight neuroscience. And when we understand the circuitry and we stop chasing the symptoms, we then can truly support development of the brain, helping our children to reach their full potential. I hope this gave all of you that watched this tonight some clarity, because this conversation that I've heard many, many times about primitive reflexes, primitive reflex abatement, the hierarchy has to be done in the right order. And so many people will start with saying, I've got to do routine primitive reflex work. And it doesn't really work that way. This is why people will come in having seen their child do primitive reflex work for months to years and never really make the kind of gains they're capable of. So the hierarchy always starts at changing input before you can change the output. If you guys have any questions, please do me a favor, drop it into the chat wherever you're at. If you're watching this through our Facebook group, feel free to drop it in there. If you're on the Facebook page, you can drop them in there. If you're reading this through Substack or some other channel, go ahead and put the comments in, and we'll get back to you with any other questions that you may have. Okay? God bless you guys. Have a great weekend.